This video is about introduction to complex numbers. And in this video, I will explain to you that what complex numbers are, why do we call them complex numbers, so on and so forth. But before we get to that, I'm just going to tell you a small story. You know, once upon a time, this is some long time back, there was an engineer who was building a bridge. Okay. This was the bridge that this guy was trying to build. All right. And of course, while you're making some structure like bridge, you better do some analysis. So this engineer was doing his analysis and he worked on this for a long time and he came up with an equation which said x square plus 2 is equal to 0. Now this equation he got after a lot of analysis. All right. And in this equation, this x, okay, stands for vibrations in the bridge. Okay. And vibration is a very important parameter of a bridge because you want to make sure your bridge is sturdy enough, so that it can sustain for a longer time and so on and so forth. So once he gets this equation, he started solving this and he wrote x square is equal to minus 2. That 2 goes on the other side. Now, when you get x square is equal to minus 2, that simply means x is equal to square root of minus 2. Now, x is the vibration and this is the answer he has got. Okay, but when he get to this answer, he came to know, oh, this value of x, which is square root of minus 2, is invalid. Okay, this is just not a valid number. Okay, so you must be having some idea about number lines. Okay, you must have done this in school. Okay, let's just say this is a number line and we usually call this as a real number line. You all know that this is going to be 0, then this is 1, 2, all the positive number on this side. And on the other side, you have minus 1, minus 2, and up to minus infinity. Now, this is typically our real numbers. Now, the point that you have to understand is what if we get something like square root of 2? Okay, if you calculate using a calculator, we know this is 1.414. Okay, so square root of 2 having value 1.414 is almost 1.5, so it has to be between 1 and 2. It is somewhere over here. That is where you have this square root of 2. Okay, so well, this number does exist on this number line. Now, what if I want a negative square root of 2? Okay, square root of 2 is 1.414, so negative square root of 2 has to be minus of 1.414, and minus of 1.414 has to be between these two numbers, right? It will be somewhere over here, and that's your minus of square root of 2. Now, the problem is, although we have square root of 2 and minus of square root of 2, what if we get square root of minus 2? Do you see the difference here? Now, this number just doesn't have any place on the number line. Okay, and that's why we started calling this number as a invalid number. You probably have heard it, that the square of a number can never be negative, right? But then now for this engineer over here, think about it, that he was building a bridge and he has done all the calculations. Okay, but people said, hey, your vibration in the bridge is just invalid. It's not a valid number. But then he went back and checked again, everything is correct. And vibrations are still square root of minus 2, which just does not exist. Okay, now comes the question that how do you deal with this type of situation? And answer to this question lies in the history. Okay, do we all know that once upon a time there were only 1, 2, 3, 4, all these numbers? We call these numbers as natural numbers, aren't they? So we had only these numbers. Do you remember at that point of time there was not even a 0? Okay, then Aryabhatta came and then he gave a 0. Okay, and then it became 0, 1, 2, 3, 4. Okay, I'm talking about when we used to live in caves, right? It's like a long time ago, right? So these are numbers, when you add 0 to it, we call them as a whole number, right? So once upon a time, even 0 did not exist. And if you see whole number, now just understand the problem with the whole number, that supposing if you have whole numbers, now you have to imagine that you are like, we're talking about thousands of years ago, okay, when we only had whole numbers. If we do 4 divided by 2, the answer is 2. Okay, so if we do this division, we get the answer. So what if we do 3 divided by 2? The 3 divided by 2 answer, and right now you know it is 1.5. But back then, when we never had that number, we never had anything between 1 and 2. There was just an empty space. Okay. And the fractions just did not exist then, right? So then you don't have 1.5. Okay. But eventually we added many more numbers to this whole system. Okay. I hope you know, then we came up with the integer numbers. Integer numbers are basically 0, 1, 2, all the positive ones, and -1, -2, all the negative ones. And then eventually we moved on to this, and we started calling this as a real numbers. Okay. And when we got to the real numbers, hey, now we have 1.5 in between. So the moral of the story that I'm trying to say, tell you here, that once upon a time, we did not even have 1.5 when we were at this level over here. So I hope you understand that that point of time, the number line, the number system wasn't complete. And hence we couldn't do something like, say, 3 by 2. Okay. So now this person who was building a bridge over here started thinking, hey, maybe this real number line is not good enough, or this real number line is maybe not complete. Okay. So what do we do now? Is my calculation wrong? No. If my calculation is correct, then there has to be a problem with the number line itself. And the idea that this guy came up with is, he said, maybe, look at this, that numbers are not on just one lines, but rather they are on two lines. Okay. So we have now two lines like this. And when you have two lines, this is called as two dimensions. So that is the idea where we say that numbers can have another dimensions, and this whole red part you have to be focused on is the basis of complex numbers. Now pay attention to what I'm saying. Now what we're going to do is, just to accommodate this square root of -2, now just see what I do. We will define square root of -1 as I. Okay, now that is going to be just by definition that square root of -1 is I. Do we also know that square root of A into B can be written as square root of A times square root of B? Correct? So that with the same logic, I can say that square root of -2 is square root of -1 times square root of 2. And we've already defined square root of -1 as I. And then we know this square root of 2 is just 1.414. So right now, if I have square root of -2, it is I 1.414. And what we do with this red line is, now we already have this 0, 1, 2. Now we will call this as 1I, okay, or just I. Then this is 2I. This is 3I. And then this is -I. This is -2I. This is -3I. Now, with this vertical line, you know what we can manage? We have this number now. We have I 1.414, and I 1.414 is right about here between I to 2I. I will have I 1.414, and that is exactly where I have square root of -2, or I can simply say this is I square root of 2, or it is nothing but I 1.414. So I basically made a space or a location for this thing over here. And now, of course, you can imagine that if I have square root of my negative square root of -2, okay, that is just going to be negative I square root of 2, or that is going to be negative I 1.414. So that negative I 1.414 value is going to be between these two, right? So now this is where you will have negative square root of -2. Okay, so I hope you understood the point of this whole story, that when you get a square of a number, the value is negative. When the square of number is negative, okay, it will definitely not fit on the real number line. So for that, we will just draw this red part. Okay, we will draw this vertical line, and now this line is called as a imaginary numbers. So all the numbers that comes with I are called as imaginary numbers. Okay, so that's where the idea of complex numbers comes into picture. What we do here is that there is a standard notation for complex number. We usually write them down as Z. Okay, and Z is always written as X plus IY. Okay, And this I basically stands for imaginary, or you can call it iota. And this is z is equal to x plus iy is how your complex number is going to look like. Okay. And the complex numbers are not on the line, but they are on the plane. So it's two dimensional. Usually students think that when we say imaginary numbers, they think that it is not a real number, and because it is not real number, it doesn't exist in the real world. Many students think like that imaginary number is something that we just imagine and they don't really exist. Okay. And that is completely a myth. Please understand that if you're doing any of the cutting edge technology, like say building a bridge or developing a new software or designing a new circuit, okay, if you're doing anything which is very computationally complex, okay, and anytime you're going to end up as a square of a term as a negative number, okay, that is when you will need complex number. That is when your real number system will fail, and your complex number will help you to solve any of the problem. I'm just going to give you a few examples of complex numbers. See, the examples are, say you have 2 plus 3i. Okay, so you have this 2 as the real part and 3 as the imaginary part. You see, this is x plus iy. Or you can have a number like 5i. Now this number is called as purely imaginary because the real part is 0 here. Or if you have 7, that's your good old real number, right? So you have imaginary part 0. So first one was a complex number which has got real and imaginary both the parts. Second one is purely imaginary. We call this a purely imaginary because the real number is 0. And this we call it as a purely real because imaginary number is 0. Okay, so these are the different types of numbers you will have. Now, going forward, we will definitely see different operations that we can perform and many other things that we can do with the complex number. They have their own properties as well. So we will be discussing all these things later on. But this is just the introduction of this is an evolution of numbers. We have evolved from just one-dimensional single real number line, like we've studied in probably school, okay, to a two-dimensional numbers where you have real and imaginary as a two parts, or it's a 2D numbers.